Hello, everybody. I don't know. This is a new dynamic for me in regards to. So, oh yeah, here we go. So you can kind of see us right here. So it's a new dynamic for me. So we can see who's watching, our numbers here, and I'll keep an eye on chat. So if anybody has any questions,
perfect,
that comes up, we can answer those.
Perfect.
Yeah, okay, so on the internet it says we are live with you now. So yeah, I'm like nerding out on it at the same time we're doing it. I did a test run or two.
Okay.
And I was like, okay, I think it's working. And I did another, like the final test run I did right before I came down to meet you. I was like, oh, the video doesn't show up. That's a problem. So hopefully the audio and video is working right now. It shows in the thing here that we have audio. So we should be good to go. And I'm just going to start because even if the stream's a little weird, I'll be able to splice it all together and put together a video between that and everything else.
Sure.
And we'll have a good premiere post facto.
Great.
So it'd be good stuff.
Great.
And I'm gonna pop over. Let's see. I think I'll keep it on this scene where it's all of us. So anyway, I'm Adrian. Some of you know already. And you are. Go ahead and introduce yourself to everybody.
Yes, I'm Archis Gore. I'm CTO for Polyverse Corporation. We're a cybersecurity company that focuses on moving target defense. And we will go into what that means in a little bit.
Yeah. So Archis has agreed to come and hang out with me and have a conversation. This is a new segment that I'm doing on the Thrashing Code channel here. So hope you enjoy it. Maybe Archis can even help me secure my boxes eventually.
Yeah.
I know right now they're kind of.
We'll take care of all of them.
They're very secure at the moment because as you can see the RJ45 cord is pulled out of the internet, so it's not on the internet.
Yeah. That's awesome.
Yeah. But cool. So I've been working on a lot of different things, and you've been telling me a little bit about Polyverse. Why don't you tell everybody else about what it is that y'all do over there?
Okay, so there's two ways of looking at what we do at Polyverse, right? The one is the social aspect, and the other is the technology aspect. The social aspect I always like to focus on first, which is why bother? What's the problem in cybersecurity? The challenge in cybersecurity that I saw, at least when
Wait a second. You're saying there's a problem in cybersecurity?
Yes, I am saying that there is a problem in cybersecurity.
Oh dear.
Right?
Sounds like a problem space.
Right. Exactly. We could, we all like to think that we have solutions, but we don't. And if anyone's a math nerd, you know the difference between. So all solutions are search solutions in the math space, right? And there's something called positive acceptance and negative acceptance. Positive acceptance means I see this and this is what I want, right? Negative acceptance is saying I see this isn't what I want, and that's the only feedback you get.
You don't want the go horse.
Yeah, but
gotcha.
But I can't articulate what I do want, and that's fundamentally the problem in cybersecurity, really, right? There are issues, there are problems that happen, and then what we do is we react to them. We, someone steals all of Equifax data, and we say, yeah, we don't want that. But if I called someone a week before Equifax happened, and I said, what is the problem with Equifax? How many people would focus on, Java deserializing, that's the problem, right? And so everything retroactively is always very accurate, right? It's very, Intel, of course, should not have done speculative execution across security zones.
The hindsight.
Right, exactly.
And hindsight's always 20/20, but beforehand, fuzzy.
But on December 31st, 2017, how many people would have said, speculative execution, that's the problem, right? And that is the problem of cybersecurity, right? It's not the scanning and the firewalls and detection and policies.
Right.
It is what is the problem? We don't know, right? We only know when we see this horse and we say, this is not what I want, right? But we can't say, give me this mug. And so the reason that problem happens is because so there's a bunch of different social aspects, right? But one quick sniff test to really fundamentally identify, do we even have a problem? Am I just bullshitting?
Right.
And a great way to call me out if I'm wrong is to ask yourself, what was one cybersecurity problem that existed in 1971 that doesn't exist today?
That's
so
who can remember 1971 though?
But so think about like all the problems we have, right? And how many problems have we solved? So like if you think of a car, right? We had problems with rigid chassis and people would slam into their front, right?
And
now the car's crushed.
Is that's supposed to make it safe?
Correct.
But it didn't.
Correct. But we fixed it. Right? Space shuttle Columbia had a disaster. We fixed it. Of course there was one disaster, but we didn't repeat the same type of disaster again. Right? So as other fields progress, there were problems, and now there are new problems, and that's how we move up. Right? That's how technology, society, we as people, we move upwards. Right? Cybersecurity.
Cross our fingers.
Yes, hopefully. Cybersecurity. We had password problems, we still have them. We had firewall problems, we still have them. We had antiviruses, we still have them. We had whatever, name something that happened in 1992, right? We still have that problem, right? And the reason is we don't have systemic reactions, right? We have very knee-jerk reactions to situations.
It's kind of like we look at this single data point and we're just like, well, we need to fix that data point.
Correct.
So if we sort of fix it, we move it a little bit, but then we just push out the problem.
Now there's a second aspect to the social side, right? Why don't we have systemic fixes? Part of it really comes down to we know what we don't want, but we don't know how to articulate what we want. And the second aspect of this is cybersecurity problems are 0-1. Right? So if Equifax had a deserialization problem, name 5 things that they could have had that would have degraded the service gracefully, right? And none of that is true. You have nothing happen until there's one password, there's one admin, there's one deserialization bug. It takes one thing and you have 100%. So it's a step function, right? But that means that as a defender, but take anything else in life, it doesn't happen that way, right? The Boeing 737 MAX, 2 of them crashed, not all of them one day, right? Yet, but then we reacted. But the point is, right? And all the planes didn't just go down all at once. Every plane, every model, right? And the answer is hidden in what I'm suggesting here. But the real key there is diversity, right? What you don't do is you don't have single points of failures. You don't have these all or nothing situations. The first thing that we as people tend to do, the reason we as humans exist is because nature did not have a single point of failure, right?
We got distributed.
Correct. We got distributed. We adapted to heat, the cold, wet weather, rainforests. We adapted everywhere. But even before us, we adapted to viruses and bacteria, and we learned to digest different food. We learned to cook. We invented agriculture, right? We diversified intellectually, we diversified genetically, and that diversity is what keeps us resilient. So something bad happens, right? And it's terrible, but it happens to a few of us, right? The whole species doesn't get wiped out. Now, that is a great, that's the best way I can explain moving target defense, right? Each of us is a moving target. Computer systems, on the other hand, are built to be the exact opposite. Every copy of Windows on the planet, literally every single copy, is byte to byte identical. And we go out of our way to make sure that that happens. What happens when you find a flaw at byte number 64? That flaw exists on every Windows computer at byte number 64. Right? That means I break one, I take all. Every Equifax record was in one big database, right? You take one, you take all. And this keeps on repeating. Capital One, that S3 bucket, right?
Oh yeah. Wait, what was the Capital One thing? It was the S3 bucket, but it was the person had the keys from internal keys or something,
there's
right?
many interpretations of that.
Oh, really?
But I mean, the thing is, we can go through what really happened, but why it happened can have many different interpretations. Right? Was it a firewall problem? Was it an ACL problem? Who knows?
Yeah.
The problem wasn't the firewall problem or the ACL problem. Here's the problem: if the firewall failed, the loss is 100.
Right.
If the ACLs fail, the loss is 100, right? Name one thing. If one person in Capital One fails, the loss is 100, right? There is no gradual loss, right? Operations doesn't work that way. You take out an availability zone and my service will go down 30%.
Right.
You take out a region, will go down 50% and will come back in a different region.
I got
right?
you. Yeah.
Security, you misconfigure one firewall, my whole company is screwed. And that is the problem in cybersecurity. It's
that
not
makes sense.
right, and that's what I call the problem.
And I can see that too, because the work I've done in InfoSec in that space has almost always been trying to kind of polymorph a solution to fix the holes as they change.
Correct.
Worked in InfoSec for a while, and it was interesting how that's done. And I also found it interesting too, the difference between like physical security versus the way InfoSec security was. Because like you mentioned, every copy of Windows is the same thing. Once you have that version, that's a copy of everything.
Right.
But like even in the physical defensive things, there was strategies, there was ideas, there was approaches, but it would polymorph to the different environments. Like you didn't do the same thing at every building. You didn't do the same thing in every hallway.
Correct.
You didn't do the same thing at like every bay.
Right.
You changed it specific to what you could determine might occur, and then you adapted
Correct.
if things occurred.
Correct.
So it was a real, I don't know, how would I put it? I guess I bluntly ran into that awareness when I was working in InfoSec at the time, that it didn't seem InfoSec had matured to a systemic view, kind of like what you're talking about.
Right.
So it's cool to know that there's at least a company working on it that way. But that's a good approach. I like that.
Yeah, and so the thing is, you have to ask. We really focus on asking the question, what then, right? I have this modeling philosophy that I call impact modeling, which is a direct antonym for threat modeling, because we don't model threats, we model impacts, right? This is a real conversation that I've had in Amazon. So I ran a little bit of Amazon.com operations for the search team for in my past career, right? Every year we'd have at least a couple of people basically talking about, if Amazon West Coast goes down, our site is going to take 1 hour to come back up, and we need active standby, right?
Oh yeah.
And that's a fair question, right? But the way that it translates, right? This is why impact modeling is important, right? If you ask the question that way, it's an unfair ask, because for Amazon West Coast to go down, you literally are talking about San Francisco, you're talking about like California, Oregon, and Washington, literally underwater. The Pacific Ring of Fire has basically erupted, right? And the biggest concern in consumers' mind in that 1 hour is, holy cow, Amazon doesn't have a failover strategy, right? So this is the real problem with some of the InfoSec threat models that we do, right? Well, could this happen? Yeah. Could an operating system spontaneously generate credentials and start beaming them out? Yes, it really could. If you ask the question, could it? The answer is always yes. The question to ask is, what then? Right? And when you ask what then, you actually reach very innovative solutions that are simpler, cheaper, easier, and just trivial.
So this is all very interesting. And I'm kind of curious, like how did you end up in this position, working for a company that's doing this type of work, especially have come from search, and that type of spectrum of work. How did you end up in this?
Actually, it was many things contributed to this. So my boss and co-founder Alex has a big background in the industry. He was CTO for AOL. Before that, he was technology advisor for Bill Gates in Microsoft, and so he was the one who hired me in Microsoft a long time ago. Bill ran some competition to find like the 20 smartest kids in India, and I happened to be one of them.
Good job.
Thank you. And so Alex and I knew each other for about 10 years, and then in Amazon, one of the things I tended to do was I ran on call for Black Friday and Cyber Monday. So I ran the entire search fleet for the 4 days, and then most of Q4 was basically I oversaw operational issues, right? And
cool.
And what would happen consistently is, and I love all the InfoSec people there, but there's always a difficult romance, right? The thing is, you always get all these Sev 2s filed on you exactly about 2 weeks before Black Friday that basically starts saying, this is wrong, this is wrong, this is wrong, this is wrong, right? Okay, I agree with you, right? Like, I'm not disagreeing with you. You're so right. Now what? Right? And they're like, well, you need to fix it. I'm like, okay, are you going to be okay if the site has a 5% outage? Right? Well, no, that's your responsibility, right? And so how do you reconcile this, right? And what really started coming to light was, and to be fair to them, right, AWS actually does do solutions, because and their security track record proves it, as well as everything that they talk about, right? But for most companies, for most of us, we just didn't have an option. What can you do?
Right.
And so that's where
I feel like that ends up being a lot of the security situations. A lot of people we know, they don't have the background to know the spectrum of things that are going on, but even companies that are trying still are at risk of breaches or whatever. And it's the case of like, well, what do they do then? They've done what they could with the resources they have.
Correct. And so in another life of mine, I actually I don't do this. I haven't done this in the past year, but I do a lot of scuba diving, a lot of exploration, and we go to some crazy dangerous locations around the world. And one of Thank you. But one of the maxims that we have is there is no deader than dead, and there is no aliver than alive. And and this is very important. What that really means is, like, if you bring someone up to like 6 inches below sea level, right? They're still going to drown, right? 1 inch below sea level, they're still going to drown, right? You either get them 100% up to the surface and you get them air, right? Or they're dead, and all levels of dead are the same. There's no qualitative difference between them, right? Once you've gotten them out on the surface and they are breathing, right? Don't do heroics and burn out, because everything above this level of water is alive, and it's qualitatively the same level of alive, right? So you want to always do everything that is necessary and no more than sufficient. And those are the two criteria that you have to meet, right? So doing the best you can doesn't mean anything. You have to do what is necessary, right? Doing more than sufficient doesn't mean anything, because once you hit sufficiency, you're okay.
That's an interesting thing, because I feel like sometimes that's what needs to be done isn't the thing that's being done.
Correct.
Well, I tried. Okay, but that meant fail.
Correct.
And in some situations, you really can't do that. You have to do better. You just have to figure out how to do better.
Right. And sometimes it's like it's okay not to do anything. And so I think like one thing I would challenge business owners to really think about is, if your teams are telling you that they can't do everything that is necessary, don't do anything, because it's all 100% failure anyway. Right. might as well do everything that's necessary and conserve the resources. The last thing you want underwater is someone who's burned through like 3 tanks of gas, and then in the last half hour you realize, man, I wish I had an extra tank of gas.
Yeah.
Right? Don't burn resources unless they're going to help. Right? But when they're going to help, burn all of them correctly, strategically, tactically, and get it done.
Yeah. It's the do or die scenario.
Yep.
Like in some situations, you have to go all in, or it's over.
Right.
Story.
Yeah, and so that's where we come in, because at about this point, all the viewers are thinking, well, holy cow, if I can't do everything, then why bother? This is such a fatalistic, this is such a cynical viewpoint, like, you know, what's the point? And that's exactly why we exist, right? To show, not only to demonstrate, not only do we build products, but we also release a bunch of open source patterns that demonstrate security can be done easily, simply, and extremely cost effectively. That's the other big trick question I have, even in the company interviews, is very few InfoSec people can evaluate, right?
Yeah.
And like, what is the cost of cybersecurity, for instance, right? And I have 3 categories, right? One is a company that is paying $1 or everything more than how much you bring in per year, right? So you're spending more to protect less, right?
Yeah.
It doesn't matter, right? Like you might be you might be making $1 million, but if you're spending $5 million protecting that million, why not just like keep 4 million instead? Like just give up the $1 million income stream, just keep the 4, and now you have $4 million instead of -4, right? The other category is you're spending more than 50%. You're spending more to protect less. Right, so you're spending 750 grand to protect $1 million, right? So you're basically protecting 250K by spending more. And then the third category you're spending less to protect more, right? And really, that's how I look at solutions, and you really can get there cheaply.
Yeah. But it seems like if you were to, how do you put it? It's one of those, like, if you don't try to wait till the last minute to do everything, and you just pay into an effort a little bit over time, you can get good security. And in many things that way, like like application development, prime example. If you start with some security in mind, you at least try a little bit. Each sprint, each effort that you're going through, you end up with some security. Correct. Versus if you wait, you have none, and then when you in the last minute need it, you can't get it.
I know what you mean. I have mixed emotions when I hear that, and the reason I have them is because I was a developer before I was a security company person.
Well, tell me about those mixed emotions.
What I mean by mixed emotions is there's a couple of dimensions to that. One dimension is, what does some security mean, right? If I do all that, is the retribution to me after a hack less?
Right.
And when for instance Meltdown and Spectre came out, did all the ops people who were compliant, did they have an easier time than those who weren't compliant?
Was valid.
Right? And so that's a moral hazard problem.
Yeah.
Right? It's like, hey, if I do all that and I still have to face all the criticism, then why not just enjoy myself?
Yeah.
Right?
No, it's a good point, and I can totally see that. And I guess what I'm thinking of is from the context of, like, let's say you know there's certain things that you should just have in place by default. Let's say encryption, for instance, and you've started and you built a way to ensure that your pipelines are encrypted. Right. You just haven't turned it on just yet.
Correct.
And somebody snags it. If you've built in the context that you know you need to do that, you can turn it on and kind of kill that problem quickly.
We'll get to that. I'm going to actually we're going to have a fun conversation on that one in a moment. But I do want to actually, you know what? Let's go there, right? So let's assume, let's say developers should do certain things, right? One of the things developers should do is use source control. What's the source control you use?
The one that is in use.
Sure. Okay, Git. Okay.
Yeah.
Now, frequently developers should commit their code. What's the command to commit code?
Oh, there's the string of them. You git add your stuff, you commit it, and then you push it.
Git commit, right? That was it. And then you have to push your code, and so you already said git push,
Right.
Okay. Everything should be SSL secured. What's the command to generate a self-signed SSL key pair?
I don't know.
Yeah, if you're on Mac, if you're on Darwin, blah, 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 OpenSSL -- foobar -- blah -- I'm such a big expert. I'm a chest thumper. I know security -- extra option, right? Let me talk about elliptic curves, and let's talk about post-quantum. Let me tell you about, right? So when we say developers should do security early, right, it is also a responsibility on us as the security community to say OpenSSL -- self-signed, and here's 2 certs, use them. You have no reason not to use them, right?
Well,
because
and that's kind of what I mean. It's like you gotta start with something.
Correct.
You gotta at least try to figure out what it is you're gonna
Correct.
do.
So which leads me to the second segue, which I always ask now I ask InfoSec people who come help us, because we also have reviews, is what is an answer that would be different if I asked you at the start of the development process versus if I asked you at the end?
Yeah.
So let's take diabetes. If I ask you before I have it, you might say cut down on sugar. After having it, take insulin shots.
Yeah,
let's take smoking, right? Lung cancer. Before I have it, stop smoking.
Right.
After I have it, here's chemo and radiation, right? But and this is why I went to the OpenSSL problem, is if I ask you before, it's still OpenSSL, blah, 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 blah. If I still do it after, it's still OpenSSL, blah, 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 blah. And that's, again, why we don't get asked. Right? We have to have better, simpler, easier solutions when asked before, and we will incentivize being asked before.
Yeah. No, that's a good point. I think, the security thing is kind of tough on, partly because it's not dealt with in a systemic way, like we're talking about. Most of the time it's like the point fix,
right,
and that's it. And then it's nothing until things go boom again, and then it's point fix.
Correct.
Well, like some of the other things, and I was talking about this earlier, there's like the whole notion of like chaos engineering and managing things from like having a chaos monkey tear down some whatever instances, environments, or whatnot. But if you can't have insight, and this is where I was kind of conversing earlier today, if you can't have insight into why a thing went down, and you don't have that, all you're doing is point fixes. So even though you have Chaos Monkey showing you what happens when that thing falls over, why did it fall over? What are you really doing about it? Or you're just doing a quick hot fix that you might make permanent, but you still need to systemically know, why did that go down? How should my application really deal with that? Should it just assume that it's dead? Should it assume something else? Should it assume that there's a cache tier somewhere with stuff in it? Like, what are the assumptions that should be made? So it's almost like if you have these chaos elements that you're modeling around or whatever, you should also have observability and insight into those things.
Correct.
Without it, you can't do accurate
before that. Even before that, you should actually have a hypothesis. You should have a theory, right? We didn't build the particle accelerator and then shoot a couple of protons at each other and then see what.
Spend like billions of dollars on that and just crack at it?
And then see what came out. We had a hypothesis that there exists something called a Higgs boson. This is how it's going to look like if it does exist. If it doesn't exist, this is what it means. If it does exist, that's what it means. Now let's go test it. So you test for a hypothesis that you expect to be true, right? This is the biggest advice. This is my most controversial advice when it comes to reliability. I will tell almost everyone to not do chaos engineering because not everyone, but most of the times, because you have to basically say that I am reliable. Like that's the statement, that's the stake in the ground. I am resilient, right? Now you test, am I for sure resilient, right? So you're basically saying my Higgs boson is that I am resilient. Right? Everything that I can do has been done, right? Then you set up the observability detectors. You say, if I'm not resilient, this is what's going to hit my photon detectors, right? That's your observability and metrics. Then you actually fire the protons. That's your chaos monkey, right? Starting with one instance and throwing chaos monkey at it is very cool. It's very sexy. It's going to sound fun on Twitter. But what does that tell you, right? Where are your detectors? Where are your, and so first you need to have that stake in the ground. B, if I'm wrong about this stake in the ground, these are my metrics. That's observability, right? And then C, I'm simply reconfirming what I already know.
So you're saying, I see.
Because
so it's kind of like you're setting up proof, and then if there's the hypothesis is proven wrong, then you're like, why?
Right, and now those metrics make sense. But having a bunch of metrics, just recording a bunch of stuff without that stake in the sand, and so you do some chaos and things go down, and you're like, oh yeah, so like here's my order graph and it went to 0. Cool. Right? So what was expected? Did you expect a failover? Was it Route 53? Was it S3? Like what was going to happen that didn't happen in this contingency?
When I think some of the I wish we could have like Charity Majors here, or somebody from the observability space, and somebody like Tammy Boutal from the Chaos Engineering company or something to like elaborate on that. Because I think some of what they're trying to do is model that. Where they're trying to get a proof and a hypothesis first, and then you have observability around specific events that you think should be happening, and then you act from that perspective. But also like some of the testing frameworks, or I don't know, maybe proof frameworks is a better way to put it. That's the point that you start from, instead of, well, I'm just going to make some random stuff happen and then sort of figure it out.
Exactly.
So it's interesting that you say that you would suggest people not to do chaos engineering, but I think based on what someone defines chaos engineering as, would they either be in agreement with you already, or then you could argue about it. But no, that's an interesting vantage point.
The best way to like really think of any measurement is before you measure it, you should have, in my head at least, for everything I measure, I know what every value of that measurement means, right? If I'm measuring, say, hits to my load balancer, right? If they're 0, I can tell you what that means. If they are 5,000 a second, I can tell you what that means, right? Because then there are two ways that I learn, right? One is they go outside of the bounds where I have these gaps. I don't know what that means. Then I go back and I figure out what that, when the value hits that gap, what does that mean, right? That's one learning. The other learning is when they don't line up with other metrics where they're supposed to, but just seeing a bunch of numbers on screen is very confusing, actually.
And I think that like from the observability circles where they're like really there's a concrete definition of observability, that would just be the dashboard monitoring problem, where it's like I got tons of data on all sorts of stuff, but I don't really know if the server went. It might be up.
And that's actually what I find more than often is
that's the vast bulk of the industry. People
will like share data and they're like, look at it, right? You're like, I'm not sure. I don't know what I'm looking at. Is this like, good?
Okay.
Like if my, so like, no, I this is true. Like when I had some vitamin blood work done, and my doctor is sitting there and he's like, your vitamin D is like between these values. Like, okay.
Yeah.
It's very useful. Like,
Right.
is it too much? Is it too little? I'm not sure, but this is it's very accurate science there.
Yeah. That's funny. Every time I get like any type of cholesterol check or whatever, they always tell me that, and I never remember what like a normal amount should be. And I'm like, what do I do? That's my question. What do I do?
Correct.
And usually the doctors are like, oh, that's normal. You just do whatever you're doing. I'm like, cool.
Yeah.
I'm gonna have a cheeseburger or something,
Correct.
Whatever. But it always cracks me up that whenever someone just gives you data, and then they assume that you know what the next step is. You may have no idea.
Yep.
Because you don't even have context when you're initially given data of why.
Exactly.
Do I have this data now? I don't know if I care.
Yep.
So that's fascinating. So aside from all of these things, do you what else? I was snooping around on the internet, and I see you have presences of yourself around for other things you do, like get involvement in the industry as a whole. What else do you do besides just the polymer stuff?
Lately, not a lot. Lately just been it's just Polyverse stuff because there's a lot going on. I'm trying to come up with a infra as code programming language for some crazy reason, like the 11th one to fix the previous 10.
Well, the other 10 weren't good enough. So get on that.
It's just because I'm playing with so we play with compilers a lot, right? We have a lot of in-house compiler experts, and part of it is that, part of it is I just have like a crazy, I know what's wrong with all of them. I know what is bugging me, and I know what that solution vaguely looks like.
Yeah.
So we'll see how that goes. That'll be all open source, public domain.
So kind of maybe a loaded question.
Yeah.
Might cause a problem.
Yeah.
But compilers, languages. So what's your favorite functional language? You got one, right?
Everyone has one. I don't have a favorite functional language. I have a favorite modeling language. And why I say that is I actually like Erlang. I love Erlang because it is very, very Prolog based, but it's not the functional aspect. The key thing in Erlang that literally everyone misses, it's almost like how everyone missed the point of small talk, and then we got C++ out of what was supposed to be message passing entities, right? Erlang has just literally one key feature, right? But it's very profound, is every thread has its own heap. Right? There is no garbage collection. Every thread, they call them processes, has its own heap.
Right.
There is zero shared memory, and you only use message passing. You give that to me in C or Golang or Rust or whatever, you've basically solved 100% or at least 99% of every programming problem that I can think of.
So, there was, Francesco in the Go community.
No.
Does a lot of Go work. Anyway, he did a talk at Go2 in Chicago a couple years ago. And it was a little controversial. I mean, he knows Go well. He knows Erlang to a degree. But what he was positing was that if you combine Go and Kubernetes, you can have the capabilities and features of Erlang. Which I thought was an interesting talk, just, if anything, from the creative aspect of thinking of it that way.
So way before actually Kubernetes Kubernetes went through two or three evolutions in my mind. But Google, and they openly admit this, they did not think of the CRDs as a use case until the community came out with it. Before that, there is a bug on Docker, on Moby now, that I filed that actually talks about why Docker should actually give me Erlang-like primitives for message passing. And I agree that Go with its so there's a couple of problems with Go. So not the fact that it's CSP based, which is fine. It's that Go still has a lot of shared memory, right? Go is mutable and shared memory, and both are very dangerous. And we use Go internally a lot, and I've been biasing towards Rust just due to that one problem, right?
I've been itching to dig into Rust more.
So-
I'm still not that familiar with it.
Right, it's fun. It's going to be a bit of a learning curve because it will prevent you from doing a bunch of things. The same thing that happened when I first played with Erlang. It's just, oh my god, like wow, this is painful because everything has to be exhaustive. Like if I have an integer and I check for the value of 1 and the value of 2, and then I forcefully have to say for all the other values, what do? I can't just ignore it.
Right.
Like if I don't do that, it doesn't compile.
Your description perfectly describes my exact experience when I started using Erlang. I was just like, oh god, what am I doing?
Right.
Period. Like,
But then you see that as a power, because I basically started hating unit tests in every other language. Because why? Oh, we got a test. What happens if I don't give it 1 or 2? And I'm like, no, that's a language problem.
Yeah.
If your language was goddamn exhaustive, like I wouldn't need a unit test and I would never run it. Does it compile? Yes, then you're fine.
Yeah.
Right?
Well,
it's like, does it compile? Great, then you don't have shared memory.
Yeah.
You don't have a deadlock. You can have a deadlock. I take that.
I'm trying to think of the. So I took a course where they had the proof library for Erlang. It might have been TLA. I don't know. It was very
So
fun.
TLA Plus is the Leslie Lampert thing. AWS uses it a lot. I'm a big fan. Actually, so my infra as code language is something towards those lines.
Okay.
I feel like the thing that we're lacking in infra as code is compositions, right? We do them. So like the difference between compositions and so infra as code today is denormalized. Right?
Okay.
So let's say, yeah, you know what I mean. You have 52 EC2 instances, let's say, right? And you define them. And you either define them in 52 blocks or use something like Pulumi or the CDK, which then writes a for loop to generate the 52 blocks, right? That is exactly like using M4 macros in C.
There's the hack in Terraform too.
Sure.
You can say count.
Sure.
And it'll attempt to do that.
But
which has always seemed kind of weird.
Correct. But the thing is, what you fail, right? And so we have this, and I've been blogging about this a lot. You'll see me like go nuts on Twitter about this. Which is the dichotomy where people say declarative, and then they say imperative, and what they really mean is denormalized declarative versus imperative, right?
Yeah.
Declarative languages can be fully Turing complete. They don't have to be, but they can be. And the difference that I always, this is how I would characterize the difference in 2 words, right? One is me giving you, you know what, like this is a great way to do this, right? This card says O'Reilly. This card says O'Reilly. This is a for loop. This card says O'Reilly, right? Even if I do a list comprehension, this card says O'Reilly, right? After you've done the list comprehension, what can you state about all these cards? There is no overall statement, right? You can point to any one card and you can say it says O'Reilly, right? In a declarative language, that is not just static configuration. You can say all cards in this deck say O'Reilly, and that is knowledge that the system now has. So you can assert over all EC2 instances or some EC2 instances, right? And so you can have these rich constructs that sort of discuss things at a high level,
Right.
but they're not imperative. But that's my rant on.
Oh, we have
Oh, wow.
a bunch of questions.
Okay.
Or some conversation.
Sure.
Let's see here. What is going on? And then of course they might just be talking about JavaScript a lot.
Oh boy.
Lily says hello.
Hello.
Phyllis. And RH Codes, thanks for joining and following. And then no reason to be sorry. Y'all can talk about JavaScript all you want to. We're talking about Erlang, so you know.
Yeah. For the record, I actually love JavaScript for many reasons. I agree that it could have been done better the first time around, but
I mean, it's a weekend though.
But it's actually a beautiful language for what it's worth. I actually really like some of the ideas in JavaScript. What
are some of the stuff you like about it?
Well, I love that it's prototypical. I love that it's single-threaded, which is a big passion of mine. Everything should be single-threaded, and you should only pass messages, right? You should have no such thing as shared threads.
Right. You like that now.
I like that. I love that because, you know, like if I had to think of like every problem in the past, every security problem and most bugs, they just go away. And so
what do you think of the Node.js paradigm where it's like it's single thread, but it's, you know, running the multitude of asynchronous actions?
It's
how that
difficult to grok your head around. We're all trying different constructs to figure that one out. I don't have any opinion on either of them. I'm fine with all of them. They're all equally annoying. This is actually where... But
I feel like we share a lot of the feelings.
But here's the thing, right? There's a large segment of bugs. It might be annoying, but the thing is, would I take annoying versus buggy?
Yeah. Lily says she likes hearing about Erlang, and Kuskoman says considering learning Elixir.
Yes.
Learn Phoenix. So.
Learn Elixir. It's a lot of fun. And Joe Armstrong, the late Joe Armstrong, who I was a big fan of. Everyone should actually watch his talk on InfoQ called, I want to say, the 10 Principles of Reliability.
Okay.
And
I think I've seen that one.
This predates the whole, you know, like the whole cloud native whatever branding that's going on. But like this is old-fashioned, like from first principles, how to build a reliable system. And you don't have to use Erlang, but go learn Elixir. It's a lot of fun. I love it.
Perfect fellow to be talking about that.
That's cool.
So, thanks for the bits and anonymous cheerleader. That's almost hard to say. Yeah, Kuskoman mentioned that he feels like a lot of people are switching from Ruby to Elixir, which I've seen that happening. And I don't know. I feel like Ruby's lost a lot of steam, but there's still definitely a community there. And they're getting, you know, they're doing stuff. They're getting stuff done, but it's not as. I think maybe because it's not as big of a threat to some of the large corporations. Maybe that's what it is.
I don't know. I mean, I know for a fact that a couple of Seattle-based companies that I'm a big fan of are fully Ruby-based.
Well, you said you're a big fan of them. Can you say who they are?
Well, yes. Well, I know for a fact that, so although Habitat is Rust, another one of my favorite languages, Chef was very much Ruby-based for a long time. But
seems like a lot of infrastructure was Ruby-based. And shifted to Go, basically. For the deployability, right? There's the static binaries, unikernels. So it's a big win. That's why we moved to Go when we started, and now we're moving off of it. That's it. That's funny how the curves go. I did work with Cloud Foundry. And myself and a couple other people, we did some of the initial the .NET extensions that added .NET capabilities to Cloud Foundry. And it was interesting from my point of view. At least I found this interesting. Some people found it somewhat masochistic, but I loved trying to get .NET stuff to work with Ruby stuff. And Cloud Foundry in the early days was all Ruby before they did the big shift. But now they got .NET. It's integrated with Go, and I don't know. It just seems like it's a little bit easier to deal with than trying to fight through some of the early stuff. But I haven't dealt with any of it in ages. I'm just like Docker, Kubernetes, and I'm done. I need to build stuff. As I move quickly.
Exactly, and that's one of the reasons why we use what makes sense. at any given time. We explored Rust 5 years ago, and we went with Go because Rust wasn't mature, and now we're moving there. And that won't be the last language be all end all. Like the one thing you learn is, you use, so I have this, I tell all my interns this, and this is the most narcissistic thing that I ever talk about, but I call it the zone of glory. Right?
Zone of glory?
Yeah.
Okay.
And so the way I visualize everything that you do, right? Let's say, well, I'm going to do this that way, right? So let's say I have a graph, and this is the x-axis, this is greatness, and this is technology progress, right? Something that many people try to do, like if you have, like, let's say you have all these technologies here, right? And you can either move that technology up, or you can accept that it exists and you can go to the very end and quickly build on top of it.
Oh, right.
Right? And so I'm one of those people who I pride myself in being not invented here, but in a positive way. Like if someone actually sent me an email saying, hey, like there's this library that does stuff, we will delete large amounts of our own code. Yeah, we'll actually throw out our own products, because you know what? That's fine, that's gone, right? Because it's a great thing, because there's always the next problem to solve. There's like, we have a backlog of 200 years. And not even joking, like I literally have a backlog of 200 years, right?
It hit me after you said it that you said 200 years. But
yeah.
I mean, it's totally plausible. I mean, the minute you start doing something, you're like, oh, now I've thought of 50,000 things
so
to do. Yeah.
Someone else comes in and they solve that. Rust takes away 50 things that we built in-house. Awesome, right? Let's delete all this code, because other people are doing my job for me. Now I can do the next job.
Yep. No, I'm a big fan of that.
Yeah.
I love it when, I saw a tweet recently, and I didn't respond to it or anything, but I just thought to myself, I'm like, yeah, pretty much same boat here. But it was like, somebody just said, I think it was, I'm always working diligently to automate myself out of a job.
Yep.
And I feel like, especially in software development, if you're not working toward eliminating what your current job is at this very minute, you're probably not working. You're either A, not working for a very big company,
right,
or B, you're being disingenuous about your career direction, because it's going to bite you eventually.
Right.
And I've been in the industry long enough that I've seen the people that are like, oh, well, it's complicated, so like it's good job security for years. No, what'll happen is eventually that app will get chunked.
Correct.
And you will be too.
Correct. No, that's very true.
Yeah.
I agree wholeheartedly, actually.
That's one that's caught me flack in the past, and I'm like, we can just wait and see then.
Right.
Because it'll happen, and I'll just be sitting here going, okay, I tried to help out.
Right.
Yeah. Cool. Well, first off, thanks for coming all the way.
Of course.
Because I know Ballard is sometimes way over yonder by the sea.
I love this area.
Yeah. It can be super chill when you know where you're trying to go. Otherwise, you get lost and you're like, oh crud, I'm in Ballard. Now I got to go completely the other way somewhere. But really appreciated having you out here.
Of course.
I'm gonna say fairly well. Adios, stream.
Bye, everyone.
We'll have a premiere later where I'll answer more questions. We can ask Archie questions. He's on Twitter.
Yeah.
I'm on Twitter. Y'all know that. So, shoot stuff at us that direction. Oh, you had a blog article stream about the last topic. Blog article. The last topic where we talked about if you aren't working to eliminate your current job, you're probably doing it wrong. That one. Because I could write you like 50 blog entries about that and elaborate on that, and probably get myself into trouble. But
yeah, you can if you go to my blog. It's not very popular, and I like it that way. But just go to Medium and search for me, and I rant about this a lot.
Cool.
Yeah.
I will on the follow up on the Twitter, on our Twitters.
Yeah.
He's Archis Gore. I'm Adrian. I'll follow up and put a bunch of stuff in there. Do a blog entry to follow up on this too, because I'll consolidate some of the videos so we can have a premiere later and rewatch what we just talked about.
Yeah.
So we will catch y'all next time. And in the meantime, happy thrashing code.
Yeah, happy thrashing code.